architect as well. So these are like basic things, introduction. And if you want to follow me in LinkedIn, you can follow me. There I used to write blogs in LinkedIn, Medium, as well as in C# blogs. You can get some good data engineering related blogs and articles over there. Okay. So now coming to the session. So today we are going to see about Databricks. Okay, like I can see a few people are joining now. Maybe, yeah, let me start. So we are going to start with Azure Databricks. Before that, we just want to know about the audience first, like whether you already worked on Databricks or you are new to Databricks, you know what is Spark, like that. If you already worked on Databricks, yeah, actually Dinesh has kept a poll in this meeting. Can you please answer to that poll? It will make me to understand. You can see a poll. It is asking, are you currently working in Spark? Okay, mostly I'm saying no as an answer. So, so this Databricks, what it is going to give us is Databricks is a separate entity. Like it is a software company. You can say it is founded by the creators of Apache Spark itself. Okay, so Apache Spark is nothing but the analytical engine, data processing analytical engine. We can say big data processing analytical engine. Then why we need this Databricks? Okay, we will see why we need Databricks. Before going to Databricks, we need to know what is Apache Spark. Okay, because this Databricks itself built over the Apache Spark only. Okay, so we can directly go and write code in Databricks and we can deploy some jobs and all. But without understanding the underlying architecture of the Apache Spark, and if you are going and writing the code in Databricks, that is not going to make any sense. Okay, that also we will see why we need to know Spark before jumping into Databricks. Okay. So now let me go to the next slide. So now coming to Spark. So as I said, Spark is an analytical engine for large-scale data processing. So it processes the data in memory and in very faster way. Okay, so if you're having terabytes of data and if you want to process the data within fractions of second or within some minutes, you can use Apache Spark for it, because Apache Spark uses the parallel processing and in-memory computing to process the data. We will see what is an in-memory, what is parallel processing and all. Just take down the points, like it is a parallel processing as well as the in-memory computing unit. Okay, this Apache Spark is. So now we know Apache Spark. Apache Spark is an engine, right? But it only do data processing. Okay, but for an end-to-end data project with only data processing engine, we cannot achieve that end-to-end project. Why? Because for a data to process, you need to store the data somewhere, right? And you also need to create some pipelines. You also need some security for the data, and you need some data governance. All those things you need. But Apache Spark provides data processing alone. But you can integrate the Apache Spark with other services. In this image, you can see Apache Spark, you can integrate with HBase, Cassandra, Kafka, okay? All those other services you can integrate so that you can get that all the big data components into a single scope, okay? So that is Apache Spark for us. So since I said Apache Spark is an analytical engine, consider Spark as an engine, okay? Consider Spark as an engine and consider Databricks as a luxurious car. Okay, so now tell me whether without understanding how the engine works, can you able to drive a car? You can drive a car, right? Without knowing how the engine works, what is the specification of the engine, also you can drive the car. Guys, am I audible, right?
Yes, yes.
Okay, so without understanding anything about the engine, you can able to drive the car. But what happens if you understand nook and corner of the engine? And if you drive a car, you will become a pro rider, right? You know everything about that car. You know everything, every functionality about the car, right? So there comes Apache Spark understanding. So if you know what is Apache Spark and how that Apache Spark architecture is built and how you can configure it, everything, then it will be easy for you to write code in Databricks and do whatever you want, the data transformation or data pipeline creation, data workflows like that. Okay, so since I said this is going to be a series of sessions, we are concentrating on Databricks, the two on Azure Databricks. Okay, I will tell you the difference between Azure Databricks, AWS Databricks, GCP Databricks, and all. Okay, so before that, we are going to concentrate on Azure Databricks for this series of sessions. So In this session, I'm planning to give you the flavor of Spark. Okay, because without knowing the Spark, if you go and write a code in Databricks, means you can write it, but it is not going to be optimized one. So in this session, in this 1 hour, we will try to see some basic architecture of Spark, components of Spark, how Spark works. Okay? Those things we will try to see today. Once you're comfortable with Spark, today we also try to see the overview of Databricks, that how the Databricks looks and what is Databricks, those kind of thing. Next session, we are planning for coding, like how you can actually start coding in Pyspark and write some transformation, do your data transformation. Okay, in the future upcoming sessions, we will go in depth about the delta table, okay, delta live tables, and all those other advanced concepts. Okay, so this is how we are planning for the series of session. Any suggestions or any doubts about this particular series of sessions? Or any other feedbacks, like you want like this, that?
Do we need any prerequisite learning to start with these sessions?
So prerequisite is in the sense, if you are good with Python and SQL, that will be good, because when we start with Pyspark coding, right, it is mostly we will write the Python code only. Okay, similar to Python, but I will not say that it is exactly Python. Pyspark might look similar to a Python code. And if you have a Python and the SQL knowledge, then you can debug any logic you want. For example, if you are getting any customer requirement, you want to write a Pyspark command, means if you know how to write a code in SQL or Python, then you can easily write the code in Pyspark as well. So that is the minimum prerequisites for this session, Python and SQL. Just the basic understanding is enough. And regarding the subscription, yeah. So regarding subscription, we are concentrating on Azure Databricks, right? So that means you need to have an Azure subscription, but that is also not mandatory. Why I'm saying is, Databricks itself, they are giving a community edition of Databricks. Okay, so at the end of the session, I will assist you all to sign up to that community edition of the Databricks. There they give free subscription to everyone. Okay, that means you don't need to pay anything. You can just log into that community edition of the Databricks. You can start writing your code, execute your code, whatever you want you can do, but there are some limitations because that is free, right? There are some limitations. We will see that limitations as well. Okay, so those are all the prerequisites. Any other questions?
Arun, one more thing. Why one need to learn Spark or Databricks?
Yeah.
Is it a, why is it a needed thing? First of all, should I learn this? Where it would be helpful for a career of a developer or someone?
Yeah. Thanks, for taking this point. So why you need to learn Databricks? So all these days we were processing our data using any of the RTBMS system, right? Maybe you might have used Oracle, or you might have used T-SQL to process your data. That means you will have your data in your table. Then you will get some requirement from the client to write some transformation. Then what you will do, you will read the data from the table, you will write some transformation, and you will give it as an output. Maybe it might be you again dump it to the table, or you will push it to some reportings. Okay, so those are all like not that much big data. But now we are in the era that is a data era. So now data is a new oil. So everything is data here. We are registering for this event. We submitted most of our personal informations like name, email ID, mobile number. All of these are data. Like on daily basis, we are dealing with a huge amount of data, right? So since all our IT employees here, we might know that data is the new oil, and we all are living with data only, right? Our companies are living with data. So there should be someone who organizes the data, right? So there should be someone who scrap the data from the sources, multiple sources, and they need to transform the data, and they need to push it to some destination. Okay, from that destination, the end users might pick the data and prepare some reports, or they will push into some databases or tables like that. Okay, so now since the data is huge nowadays, that big data came into existence. So what we need to do is we need to overcome that slowness in the data processing. If you process your data in SQL or in any of your RDBMS, it is going to take more time. For example, if you are going to process 1 terabyte of data in SQL or Oracle, it is going to take more time. But nowadays we don't have that much time, right? If you do something, immediately you need the result. Okay, so there comes this Spark. When you want to process anything parallelly, you need Spark. So there comes why you need to learn Spark. Okay, so now you learned Spark, but why you need Databricks? As I said, Spark is a kind of engine. Okay, Databricks is a kind of luxury car. So that luxury car will have everything. It will have the connectors, n number of connectors it will have. It will have Delta Lake, it will have Delta Light Table, workflows. You can schedule your job, whatever you want, you can do it in the Databricks itself. So that is why you need to learn Databricks. Any doubt in this?
Anyone else, guys? If you want to give a try. So doing this series of sessions is basically to transfer the knowledge. You can get this information from a number of channels or Udemy courses or anywhere, but it will be tutorial based. What is Databricks? What are the features, kind of thing. But while it is being spoken from a person who is working in Spark and Databricks every day, then it will be kind of sharing the experience. And as attendees, you can also communicate with the during the session and learn that experience. Learning the concept is easy, but learning the experience is difficult. That is what we are trying to establish. So any feedbacks would be great, and may not be now. You can also reach out to me or Harun via LinkedIn and share your perspective. And Harun, can I take a perspective to a minute to share about the next session's link as well in this session? Okay,
Yeah, sure, Dinesh.
I will take the moment to. So as we told, this is going to be a series of sessions, and the part 2 of this is scheduled again online on next Thursday. So I have pinged a meetup link in the chat, so you can click on register for the same. And probably we are going to plan the third session as hybrid or as in person at Chennai. So based on how we are going with the this first part and the second part, based on the interactions, based on the learnings, based on the feedback from the audience, we'll be planning the part 3 as in person or hybrid. Yeah. Yep. Arun, it's your stage now.
Yeah, thanks, Dinesh. So now you all got some idea why you need Spark and why you need Databricks, right? So any doubts, further doubts in that? Why Databricks? Okay. If you all are good, then we will start with that. So as I said, before learning about Databricks, we need to know about the Spark, right? So as discussed, today we will see some topics about this Spark alone. Okay, what is Spark architecture, how it actually works. Okay, everything we will see today. Okay, you can stop me whenever you want. You have any doubt, means you can stop me. Okay, let me share my screen. Okay. So now coming to Spark, Spark is an analytics engine, we know, and this is the basic architecture of Spark. Okay, so the basic architecture in the sense, here you can see the Spark core engine, right? So that is the engine where all our data is going to get processed. And over the Spark engine, you can see Spark SQL, Spark Streaming, Spark mlib, and graphics. So here, this so this is an engine, and the Spark SQL and Spark Streaming is for data engineering. Okay, so in Spark SQL is nothing but you can write some SQL like queries. Okay, you can consider your data as present in a table, and you can write your SQL like queries in Databricks, and you can process your data. And Spark Streaming. So streaming is nothing but any real-time data if you want to process, that is streaming. So you need to understand what is batch and stream. So I hope you all know that like batch is like your NEFT transaction in your banking, and stream is like your IFS, your immediate fund transfer, right? So that is streaming. Okay, so these two belongs to data engineer. So then what is Spark mlib? That is a machine learning. Okay, so if you want to perform any machine learning modules in Databricks, sorry, in Spark, you can go with the Spark mlib. And if you have any graph databases and you want to perform that data over there, you can go with the graphics. Okay, so we are going to concentrate on the Spark SQL and Spark streaming. Spark streaming, it's a kind of advanced concept. Yeah, we will see that in our upcoming sessions. Okay. So this is a Spark core engine, and we have this Yarn, Mesos, standalone scheduler, or Kubernetes. These are all cluster managers. Okay, any one cluster manager is needed. Why we need a cluster manager? We need a cluster manager to negotiate resources for our executors. We will see what is resources and executors and all. But understand, any one cluster manager is enough for us. Okay, we have 4 different cluster managers. Based on our requirement and based on the need, we can choose any one from this. Okay, so this is the underlying basic architecture of Spark. So now Spark is always like a master slave architecture. Okay, so master slave in the sense, okay, before coming to this Spark architecture, let me tell you a small thing. You just visualize it. Okay, so consider there is a classroom, and in that classroom, teacher is standing and the students are sitting in bench. Okay, like some 10 benches are there. In each bench, 2 to 3 students are sitting. Now teacher got a bag of chocolate. Okay, she got a bag of chocolates. So now she wants to count how many chocolates are there. But instead of she itself counting, what she did is she's checking which are all the students are sitting idle. Some of the students are reading books and some of the students are sitting idle. So she noticed a few idle students, and she gave some bunch of chocolates to each of the idle students and asked them to count. So now each and every student is counting what amount of chocolate they got. For example, student from bench 1 got some 5 chocolate, he counted as 5 and he reported to teacher. Like that, from different benches, different students calculated and they reported to teacher. Now teacher got to know that she is having some 150 or 180 chocolates in that particular bag. Okay, so now tell me, the teacher itself can counted the chocolates, right? Why she gave to the students? What she achieved here?
The time consumption is more when teacher counts.
Yes, time consumption is more, because as a single person, if teacher starts counting that 150 chocolate is good, it is going to take more time. Since there are idle students, right? They are not doing anything and sitting simply. She asked them to do the work. Okay, so now the time is also very less comparatively. When a single person doing that work, comparatively it is very less. You can relate this to your team also. Since you are all in IT, your team manager, what he will get a project. What he will do, he will split the work, and based on the experience of the team member, he will give the team members some work, and the team members will complete the work, and he or she will report to the team leader, right? So that is a kind of master slave architecture. Okay, so here the Spark does the same. Here you can see the driver is there. Okay, so this is a driver. You can call it as a master. Okay, driver, and here executors. Executors, you can call it as a workers. Okay, so a driver and worker we can say. Okay, so if you see here, whatever the code you are writing, it will go to this driver. So the driver, what it will do, it will split the work and it will give it to the executors. Okay, so the executors will actually do the work in the sense the data transformation. Okay, for example, you are getting some 1 terabyte of data. So within a single system itself, if you are going to process that 1 terabyte of data, means it is going to take more time. Instead of that, what I'm doing, so execute. Okay, before that, driver process is one machine. Okay, it is one JVM, that is a Java virtual machine. This executor 1 is one machine. This is one machine. This is one machine, and this is one machine. Now this is consider 5th machine. Now I have 5 nodes. 5 nodes in the sense, one node consider as a one machine. Okay, so now I have 5 nodes. In that, 1 is driver, other 4 are executors or workers. So now if I have 1 terabyte of data, I can give it to the driver. This driver will analyze and it will split this 1 terabyte of data into a chunk of data that we will call it as data partition. So this entire 1 terabyte is called as data set, and the chunk of data 1 terabyte will get splitted into, consider we are splitting into 4. Okay, so this one is called data set. This is called data set. This is called data set. So each and every executors, I'm going to give this data set. Okay, and the code I submitted to the Spark session will act upon this data set. The data will get processed, and the executors will report back to Spark session, that is the driver process, saying that I completed the work. So then now the driver process will give the output to the user. So this is how it works. Then what this cluster manager is doing? So cluster manager is a kind of a resource negotiator. Okay, he is going to sit between this driver process and executor process. Whenever we submit something to the driver process, to allocate the resource to the executors, they will come and request this cluster manager only. So this cluster manager will allocate the resource to executors. Okay, so resource in the sense the CPU or memory, that is a resource. Okay, so consider each and everything is a machine. You can consider that as a simply your laptop or PC desktop also. Okay, that is a machine. So here it is a virtual machine. Virtual machine in the sense you are not going to have it as a physical machine. You can consider that as a virtual machine. Somewhere it is running. You are going to utilize that CPU and memory and everything from it. Okay. So altogether, this is called as a cluster. Cluster is nothing but a group of machine. Okay. Always there should be minimum one driver node should be there. One driver node is mandatory, and 0 to n number of executors you can have. Okay. Because why I said 0 executors, if you have 0 executors, that means driver node itself will act as a worker node also. For example, I said community edition of Databricks, right? That time you will come to know why I said this 0 executors, because since that is a free version, they will not give executors. That means they will give only single node for each users. Okay, so that time driver node itself will work as a worker node. Okay, but depends upon your data size and it depends upon your data flow, everything. You can decide how many executors you want. Okay, and one more thing is, inside a single node, you can have multiple executors as well. Okay, so here I have one executors, right? So instead of that, I can have one node. Inside of one node, I can have 2 to 4 executors also. It all depends on how much we are spending on the machine. Okay, the JVMs, how we are going to spend it. Okay, so it totally depends on our requirement. So that is master slave architecture. So that is what driver and executors does, and that is what cluster is. Any doubt in this cluster or the master slave architecture? Okay, I'm considering. Yeah, someone is saying something.
Harun,
Can we have more than one driver?
No, more than one driver we cannot have. Only one driver we can have.
Harun, in the programming itself, we will be able to manipulate the number of executors we need.
Yeah, so when it comes to Spark, you can configure it. Spark is configurable. If you have some resources and you want to decide how many executors you want, how many cores. Okay, let me come to the core. Okay, so in programming itself, you can configure it, how many executors you want and all. That is a configuration, Spark configuration. So what is okay, any other doubt in this?
No, I'm good.
Okay, nice. So executors, I said, right? Inside executor, what will be there? So when you are purchasing a laptop or desktop, you will say that a dual core machine or a octa core machine, right? What that means? What is dual core machine?
2 processes, multiprocessing.
Multiprocessing, parallel processing. Okay, so I have seen system worked on Pentium 4, then dual core, octa core, now i5, i9, right? What we are seeing drastically, the speed, the multiprocessing, parallel processing, we are doing multiple operations nowadays, right? But in Pentium 4 and all, we cannot do that. If you are in one window, then you can do that alone. If you are opening any other window, the system will become slow. That means some parallel processing is not possible then. So that is cores. Okay, so now inside executors, there will be a slots. The slot, you can call it as a slot or core or thread. Okay, so inside executor, there can be a number of slots. That also depends on your configuration. So this slots only performs the task. Okay, so the slots defines whether you are doing the work parallelly or not. If you start increasing the slots, then it will be like you will get more space for the task to accomplish in a single executor. But we cannot go beyond a certain slot also, because, for example, consider this one executor. Okay, one executor is kind of some 16 GB RAM. Okay, and some 256 GB memory machine. Okay, so now you can split this executor into some 4 cores, means each core will get 4 GB of RAM. Okay, and 256 divided by 4, that much memory it will get. Okay, so like that, based on the configuration of the executor, you can decide how many cores you want in the executor as well. That is also configuration. You can do that configuration in Apache Spark. Okay, so all these are configurations, configurable, and you can do that configuration in Apache Spark. But when it comes to Databricks, you don't need to worry about anything. Okay, and I said one more thing, right? So instead of executor, it will be like consider here you have a node and you have one more executor. You have 4 executors. Okay, in Spark you can have a node, and inside the node you can have one executor. Okay, so this is one node. This node is having one executor, and this node is also having one executor. But this 4th node is having 4 executors. Okay, but in Databricks, especially in Azure Databricks, there will be always one executor per node. Okay, you need to remember that in Azure Databricks, there is always one executor per worker node. Then you can ask, why we have only one executor per worker node in Azure Databricks? Because that is a managed service. They manage it very well so that the parallel processing can happen in an efficient way. Okay, so that is the difference between the native Apache Spark and the Azure Databricks. So these configurations and all, we no need to worry about when we are writing the actual code, when we are using Databricks. Okay, but in native Apache Spark, you can configure n number of things, and you can configure the executor scores and those kind of things. Okay, so that is the difference, major difference between the native Apache Spark and Azure Databricks. Okay, so this is driver and executors. Okay. Any doubt in this drivers and executors? How it gets the task, how it completes everything?
So Harun, what's the difference between client server architecture and this master slave?
So client server and master slave both are like terminology only differs. Master slave or client server in Hadoop, we will say something, I forgot it. Master slave we will say in Hadoop. Here we will say client server architecture. That means you have one person here who controls the other person. You can say this as a client and these are the servers. And you can say this as a master, these are the workers, like that. Just the terminology is differs. Any other questions? Okay. So now, so we saw about that drivers and executors, how it works, right? So now, this is how exactly it works in the backend. Okay. Now, I hope you can see this, but it is very small. This is simply like you are reading some data and you are going to count how many records are there. Okay. So this is a code. So you are step 1, you are submitting the code to the Spark driver. From the machine, you are submitting it. So what will happen? The Spark driver will start the Spark context and it will create a plan. Okay, it will create the logical plan, and from the logical plan, it will create a physical plan, and it will create n number of tasks. We will see what is task, everything. Okay, excuse me. So I will explain you in some time what is task, what is stage and all. Okay, but just understand, once you submit the code to the Spark driver, it will create this task scheduler and it will create a physical plan and it will create a task. Okay, so this task only will be provided to the executors and the executor will work on the task. Okay, so step 2 is creating the task scheduler. Okay, so step 3, what it will happen? It will go for the resource negotiation. I said, right, cluster manager role is to negotiate the resources. So it will go to the cluster manager and it will say, I got this much work and I need these many resources. Okay, for each executors, like that. So the cluster manager will allocate the resource to the executors. That is step 3. Okay, the step 4, step 4 is allocating the resource. So step 5 is the executors will get registered to the Spark driver stating that, hey, I got this work and I'm going to work on this. And once it got completed, it will report back to the Spark driver itself. So this is how internally the Spark works. Any doubt in this? Okay. So this is the basic architecture of Spark. I just explained in the layman term. Okay. You can learn more about the Spark architecture in depth if you want, like what is driver, how you can configure it further, cluster manager, how you can configure it. Okay. There are a lot of deployment modes are there. Okay. So those things and all, if you want, you can learn if you're going to work on native Apache Spark. Okay, but if you're going to work on Azure Databricks, then I think these informations are more than enough for you. Okay, like how it works in the backend, it is enough, but you need to, when you started actually working on the Databricks, you'll automatically learn all those things, because without knowing that, you cannot write optimized code. Okay, but this is good for a start. So now we are going to see some components of this Apache Spark. So we discussed about the data partition, right? So that is what this partition is going to tell about. Already I said, right, 1 terabyte of data, you are going to partition into small chunks, and each chunks you will give it to executor nodes. That means these are all the executors, right? For example, you are getting some 4 GB of data. Each executors you will give 1 GB. And these worker nodes will work on 1 GB of data, and it will report back to the Spark driver. Okay, so that is data partition. So this data partition also you can configure, like how many partition you want to create. So based on the executors, for it is simple. Consider like this: you are having a team, okay, and you are getting some project, some data cleansing project. Okay, so your manager is saying that, hey, you are having a team, and check how many resources are available today, and based on your resource availability, get the data from me and do the data cleansing and give it to me today. So as a team leader, what you are going to do, you are going to check, okay, I have 4 resources today, so give me some 4 deck of data. You will get some 4 deck of data, give it to your team members, they will complete and give it to you, you go and submit to your manager. Okay, so now the TL decides how much resources are available and how much data if I take, it will be efficient. If the TL, like if he's not forecasting properly, and if he's saying that, hi manager, I can do whatever work you are giving, give me some 100 decks of data, I can do it. If he is asking that 100 deck of data, he cannot do that work in a single day, because he's having only 4 resources in his team. Okay, so this all you need to do a trial and error, and you need to understand how many resources you want, how many data partitions you need to create. Okay, all those comes in experience, like when you start writing codes, and when you're seeing some slowness, you will understand why my code is running slow. That time you will come to know, okay, my executors are only 4, but I'm giving some large chunks of data or very smaller chunks of data. Okay, so I need to optimize this. I need to do some trial and error method, and I need to increase or decrease the executors, or I need to increase or decrease the size of the partition. Okay, these all comes as a trial and error. Once you get experienced in that, you can easily forecast it. How much executor I want, what is the data partition I need to allocate, those kind of things you will get to know. Okay, so that is what data partition is. So now coming to the APIs. Okay, so whenever you speak about a data processing, we will say in part, if someone worked on pandas, you will say data frames. Okay, load the data into the data frame, do the transformation, then print it. Okay, so data frame is a kind of an API, and data set is also an API. RDD is also an API, but RDD is the fundamental data structure for Spark. Okay, so that is what the Spark started with. When they launched the Spark 1.0 version, they started with RDD in the year 2011. Okay, then in RDD they don't have this tabular structure kind of data processing. That means the rows and columns and all they don't have. So then in the year 2013 they implemented they introduced the API, data frame API, and in the year 2015 they introduced data set API. So data set, in this diagram you can understand data set having the functionality of both RDD and data frame. But for some reason data set is slower than data frames, and data set is not supported for Python language. So mostly as a data engineer, we will go with the data frames only. That means we will use data frame API to read our data. When doing the transformation, we will load the data into the data frame only. Okay. But if you want to do any low-level data transformation, RDDs also sometimes we will go. But whatever it is, data set or data frame, whatever it is you are writing, underlying structure is RDD we discussed, right? That is the fundamental data structure of Spark. So whatever API you write, at the end, it will convert into RDD, and that RDD only it will get processed in the Spark engine. Okay, so that is like similar to the machine learning, machine language. Okay, in our system, whatever you do, at the end, what is happening? Everything is converted into zeros and ones. Similar here also, in dataset API, you load the data, transform the data, whatever you do. In data frame API also, you do whatever you want. At the end, it will convert it to an RDD, and then RDD only it will process. RDD means nothing but resilient distributed data set. Resilient in the sense, If it fails also, it will bounce back to the original state, the data set. For example, here, to the previous slide. So here you have the executors, right? Now you have the data, 1 terabyte of data. Now you split that 1 terabyte of data and given some data partitions to each executors. So this is an RDD, resilient distributed data set. So now consider this executor as a machine. This machine fails. It might happen. Okay, this machine fails in the middle of some transformation. This RDD is doing some transformation. For example, in RDD you are getting a data. Okay, some salary you are getting 100. So you are doing some transformation. 100 plus 20% you are adding, so 20. And then you are deducting some 30% of tax. So like that, this is one transformation, this is one transformation, this is one transformation. So while doing the second transformation, the executor failed. That means what will happen? So executor fails means the entire process will not fail here. Only this executor fails. So the executor will start at some point of time. Okay, that means if the executor, it will start again. So when it is starting, since this is a resilient distributed data set, it will not start the transformation from first. It will start the transformation from where it left. That is RDD, resilient distributed data set. Okay. So only I'm saying whether it is a data frame or data set API you are writing, at the end it will convert it to RDD and it will process in the executor nodes. Okay. So in our upcoming sessions, mostly we will use data frames only. Okay. Yeah. So okay, now coming to the operations. What operation we can do in this Spark? We can do two operations. Okay, one is transformations and another is an action. So what is transformation? Transformation is nothing but doing some manipulation to your data, like adding a column or removing a column or concatenating two columns. Whatever manipulation you are doing to your data, that is transformation. And what is action? Action is like printing the result. Simply you can say printing the result. So Spark, we have something called lazy evaluation. Okay, so what is lazy evaluation is, until and then you call an action, the transformation will not happen. Okay, for example, you are having some 100 lines of code. Okay, some 100 lines of code. You are reading a data. Just pseudocode I'm writing. Okay, because we didn't start with Pyspark. Just a pseudocode I'm writing. You are having data. Consider some student data you are having. Okay, so that student data, what you're going to do is you're going to filter some student information from roll number 1 to 50. That is the first transformation. Then second transformation, you are going to do some summation of their midterm exam mark. Okay, you're doing some transformation like that. Some 100 transformations you are doing. All these are transformations, but you are not printing any result. Without achieving any output, why that Spark engine needs to work? Okay, you are not getting any result. Spark is thinking like that. You are not getting any result from this. Then why I need to spend my resources to do all these 100 lines of transformation? So in the next line, if I say dot count or dot collect, then only the Spark will do this transformation. It's a bottom to top approach. Whenever you are executing a code, it will check whether you have an action or not. The action is there, then only this transformation code will execute at all. Otherwise, this will not execute. Okay, so that is called as lazy evaluation. Any doubt in this transformation and action and lazy evaluation? In our upcoming sessions, we will see this. When you are actually writing a code, we will write some 2 to 3 lines of transformations and we will execute that. It will complete in fraction of seconds, but it will not perform any transformation over the data. Once you call that action, that time only it will perform the transformation. Any doubt in this? Is it understandable, or it's like I'm confusing you all because I'm not hearing anything back from you guys?
It's crystal clear, Arun.
Yes, yes. Yeah. So if you're not understanding also, please stop me then and there and clear your doubts, so that when we are, because how I framed is like from scratch, I planned like the architecture to transformation and some advanced concepts. So if you lag somewhere, then it will be like you lost some part. so that when you are moving to advanced concept, you might not understand that feature. Okay, so when you are finding something difficulty in understanding, let me know. I will explain you again also. Okay, so this is RDD operations. Now the transformations we are doing, right? There are two kinds of transformation. One is narrow transformation, and another one is a wider transformation. So what is narrow transformation? Now again, I'm going to take one example. For example, say in the student record I am taking. Okay, so student means what will happen? What will have ID? It will have marks. It will have then name. It will have then some location. Okay, location. Please bear with my handwriting. I'm just writing with the mouse. Okay, so it is having these kind of data. Okay, so now you want to do some transformation. Consider you want to do some filtration. You want to filter student ID who is having ID of 50. Okay, so what is the pseudocode in SQL? What you will do? Select star from student where ID is equals to 50. So now consider this student data set is 1 terabyte. Okay, student data set is 1 terabyte, and this is one partition or one node. Okay, this is one node, this is second node, and this is third node. So in this 1 terabyte of data, you divide it by 3 and give it to each nodes. That means some student information is available in this data set, and this data set, and this data set. Student informations are split into 3 data sets and available in each nodes. So now if I say filter, now I am going to check in this node if the ID is there or not. Select star from student where ID is equals to 50. It may or may not be here. If it is here, I am going to get it from this node. Okay, this node I am getting the output. If it is in this node, I'm going to get it from here, or if it is in this node, I'm going to get it from here. Or else select star from student where ID ranges from 50 to 100. That also fine, right? If it is present here, directly I'm getting it. So this is like narrow transformation. You're not disturbing anything here. From each partition, you are getting some data. That's it. But what is wider transformation? Now you want to do some aggregation. So we have the mark column here. So now I need to know what is the particular student's midterm mark, first term mark, what it is, second term mark, what it is, like that I need to know. Okay, here student IDs are like segregated in different partitions. Take same here, 3 partitions. Okay, 3 partitions are here. So now student records are segregated in different partition. Now to do that aggregation, what you will do in SQL? Basic syntax, what you will do? You will simply group by, right? Group by the student ID, and you will do a summation over the mark he obtained. Am I right? Guys, can you able to imagine with your SQL? Yes, no?
Yes, yes.
Okay, so now I need to do some group by, because student ID 1 with the term 1 mark present here, and the same student ID 1 with the term 2 mark is present here, and student ID 1 with the term 3 mark present here. But I want to know the summation of all the term marks to calculate his annual mark. Okay, so to do that, I need to do a group by the student ID, and I need to make a communication between the nodes here, because this node and this node should communicate. Then only these 2 mark will get combined. Okay, so now here you are making the nodes to communicate with each other. That is called as wider transformation. But in the previous case, we didn't make the nodes to communicate with each other. Okay, so here the nodes are communicating with each other, and here you got student 1 the total term mark, student 2 total term mark, and student 3 total term mark. Here you can identify with the colors. So this student's total term mark came from this node, and this green node, and this blue node as well. So like that you can assume. Okay, so wider transformation means you are making the nodes to communicate with each other, and you are doing some transformation there. Okay, so that is the difference between narrow and wider transformation. But when you are doing this wider transformation, since you are making the nodes to communicate with each other, there something happens called the shuffling. You are basically shuffling the data between the nodes, right? So that terminology is called as shuffling, and shuffling is one of the costliest operation in Spark. Why? Because you are using more resources here, right? So shuffling is one of the costliest operation. So this is how shuffling will be. So Based on number of shuffles, stages will get created. Okay, just understand this terminology alone. Based on number of shuffles, number of stages will get created. Here, 3 shuffling is happening. So stage 1, stage 2, stage 3 is getting created. Okay, in the next slide, I will explain you what is stage and how it depends on the jobs and tasks and all. Okay, till here, any doubt? The types of transformation and the terminology called shuffling. Any doubt till here? Okay, so now coming to the next slide, that is what is job, what is stage, and what is a task. You know what is stage? Can anyone explain what is stage? Just know we saw. Based on the number of shuffling is happening, number of stage will get created. Am I right? So then what is job? Based on the number of action, jobs will get created. For example, you're writing a code. Okay, you're writing a code like a data frame dot. You're adding some column. You're adding some column, and you are saying at the end you are saying collect, or you are saying a write to the disk. That is action. Okay, any action you are calling, I called one action, so one job will get created. Okay, if I do some 2 to 3 actions, then 2 to 3 jobs will get created. So based on the number of actions, number of jobs will get created, and based on the number of shuffling, the number of stages will get created. Each stage will have its own set of tasks. This number of tasks depends totally on how much data partitions we are having. Okay, so that is how this job, stage, and task are interrelated. So I can show you this image so that you can understand in a better way. Yeah, here only. So if you see here, when you submitted your code, what is happening? Here the tasks are getting generated, right? Task scheduler is generating the task, right? So here only it will come to know how many stages are there, and each stage how many tasks it is having. Okay, so based on the action, it will create number of jobs, stages, and tasks, and it will give it to the executors. Okay, so that is job, stage, and task. I'm just repeating it again. Based on the number of actions, number of jobs will get created. Based on number of shuffling, stages will get created. Based on number of data partitions, task will get created. Okay. Any doubt in this? Okay. We'll move to the next slide. So we discussed.
Right.
Yeah.
All these artifacts are like going with the internals of Spark engineering itself. How
Yes.
the Spark works within. We say it is not like going to the driving class. First of all, the driver teacher opens up the bonnet and explains about the engine. So it would be the session is going in that way. So how to drive the car, it will be on the series of on the next sessions, right? So
Exactly.
Why we are doing this is while practicing with the code, injecting some data, transforming and storing it somewhere. The same artifacts will be running behind the APIs you will be calling in the code. So you will better understand and stick with the logic. And even though you are not going to use in your work right now, or you are going to use in the work right now, the thing will be staying in the mind for last long. Yes. Sorry, Harun. Yeah.
Yeah, thanks for that. So yeah, exactly what you said is right. Like it is not a driving class. It is like I'm explaining you the artifacts of the car and how it looks, everything. So when you're driving, you can safely drive. Okay, even if the car stops in the middle, also you know what to do. That is what this session is exactly. Okay, so now we discussed this Spark is in-memory processing, parallel processing. So parallel processing we saw. Where we saw parallel processing is because we have n number of executors here. So at the same time, multiple tasks are happening. So that is called as parallel processing. Then what is in-memory processing? So in-memory processing means catching. One of the important concept is catching. So what is catch? So in general term, we will say, I clear the cache memory, I clear the Chrome cache. So what is cache? Can anyone explain? General cache, what it is?
It's a temporary memory. To
Kind
store
of
temporary data.
Metadata, temporary data. Okay. So for example, in Google Chrome, what you will call it as a cache, the frequently used websites, it will store it in the cache memory, so that whenever you are typing www dot, it will automatically show Gmail, or it will show your company URLs, right? That is a cache memory. So here in Spark, what is cache? Why we are going to use caches? So see here, without catching. So this part is without catching. Okay. Without catching, what is going to happen? From the input, that means I'm having a disk. Okay. I'm having some storage. From the storage, I want to do some transformation. So what I will do, I will read it, I will do the transformation, and I will give it to the output. Okay. Again, the same input, I need to do some other transformation. So again, I'm going to read it from the source. I'm doing the transformation, giving it the output. So like that, each and every time I'm going to the disk and reading it, doing the transformation. So always we know reading and writing from the disk is costliest operation, right? From even the normal machines, whatever we are using, reading and writing is it is going to take more time. So here, each and every time you are reading it from the same source. To avoid that, what you can do, you can read that data, keep it in the cache memory, nothing but your RAM memory. Okay. So each and every time, don't go and read it from the disk. Read it from the cache memory itself. Do the transformation, give it to the output. That is called as in-memory processing. Processing your data from the RAM level itself. Not every time from the disk. You are going to read it from every time from disk. You are going to read the data from cache memory itself. Okay. So that is called as caching. So how in real time it works in Databricks is, let me give you an example. For example, consider you loaded some data into a data frame. Okay. Maybe some might understand what is data frame. Consider this data frame as a variable. Okay. So I loaded a data. So this is a data I loaded. And this is my code. Okay. First line of code. Like that, I have 100 lines of code. Okay. So now in between also I have other data frame called df1. Okay. And some data is there. Like that, I have multiple codes in my 100 lines of code. So at the end, again, if I want to use the same data frame, okay, what will happen? In this data frame, what I'm doing, I'm going to read it from somewhere. I will say that read from SQL. Okay. So each and every time it will read from the SQL and put it inside the DF. So if I want to use the data frame in the 101 line also, excuse me. So even if I want to read the data frame again, what will happen? This will read from the SQL again. That is like it is going to take again some time. So instead of that, what I'm going to do, once I read the data from SQL inside the data frame, I will say df.catch. That means I'm storing this data in the in-memory. So in the 101st line, I'm coming here, and if I say df.display, it will not read the data from SQL. It will read the data from catch because I already cached the data in my in-memory. So if you know that you are going to use the data again and again in your coding or in your project, you can cache that and keep. Okay, so that is called as caching. Any doubt in this? All clear, right? Regarding this caching. Okay. So next one is DAG. DAG is nothing but directed acyclic graph. That means it will go in the single direction only. I'm not going to explain in depth of this DAG now itself because it is like too much of information on a single day. So I'll just give you the overview. So DAGs are nothing but you write some code in the backend, DAG will get created. So you might have seen the similar kind of representation in our initial slides. See, when you submitted the code, the Spark context created a DAG. So here the DAG got created. So this DAG will hold all this optimization. Okay, all those things it will have. That is called as DAG. Maybe later on we can spend. If you really want to understand in-depth architecture of Spark, we can spend one session for it. Okay, so that is DAG. Okay, and this is how inside the DAG that optimization will happen. Maybe I can provide some link. I have written a blog about this optimization how it works, each and every step, how it works. I will give you that link. If you want to understand, you can go through that link. So this is what the basics of the Apache Spark architecture. Okay. So I think now itself we are over with the time, but I just want to quickly show you how this Databricks looks. Okay. If you all are okay, then can I take 10 more minutes from you all? Or if you have any hard stop, you can leave this meeting. If you all are okay, let me know. Yeah, you can put a thumbs up. I can show you how the Databricks will looks like. Okay, fine, thanks. Okay, so let me share the screen. Azure Databricks. So this is Azure portal. Okay, slowly, I think. Okay, so this is Azure portal. Since we are going to see about Azure Databricks, this Databricks is managed by Azure. Okay, you can have AWS Databricks. That means that Databricks is managed by AWS, GCP Databricks. So what is the need of Azure here? We discussed about that driver and workers, right? Those are all the machines. Okay, so you need some units. That means resourcing units, right? Some machines you need. Who is going to provide that machines to you? Practically, you cannot have hundreds of machines in your office. Okay, so that is going to cost you more as well. Even if you are maintaining your own data center, that is going to cost you more. Okay, so who is going to provide you that machine? Azure is going to provide you that machine. If you know what is Azure, what is cloud computing, cloud providers, Azure is one of the cloud provider. So they can provide you a virtual machine. So that virtual machine, you can use it for your driver and your workers. Okay, so there comes the Azure Databricks. If you see here, this is Azure Databricks. And I will just open and show you the workspace alone. The next session, we will start from Azure Databricks itself. Okay, because now we all know what is Databricks and what is Spark, right? So from next session, we will directly start from Databricks, and we'll start with the Pyspark commands on how to read the data, how to transform the data and all. So this is how the Databricks workspace will looks like. So here you will have a workspace. Under the workspace, you will have your users. So you can go inside the user. You can create a notebook. Just the overview I'm giving. Okay. From next session, we will see in depth of this. So this is the notebook. It's like a UI will be very easy to understand. You can start writing your code and execute it here. Okay. So this is how the Databricks works. And I said community edition of Databricks, right? I'm going to paste one link in the chat window. Okay. So I want one volunteer because I already have this community edition. You can share your, okay. Dinesh, do you have this community edition of Databricks?
No, I think I don't have. Maybe I can.
Okay. Yeah, you can. Okay. Dinesh will share the screen. I will make him to subscribe to this free community edition of Databricks. You also can parallelly do that. Okay, so what this community edition of Databricks is going to do is it is going to give a lifetime free Databricks environment, because this Azure environment I showed, right? For that I need to pay monthly, pay as you go. If it is an organization level, you don't need to worry about it. They are going to pay. But while learning unnecessarily, why you need to pay? So you can use this community edition. Okay, yeah, you can see once you open the link, it will be like this. You can click on sign up. It will be a simple step only, but one point of time you will make a mistake. I don't want you all to make that mistake. Okay, you can fill up your information. I will tell you where most of the guys will do that mistake. Okay. You can click on continue. Yeah, here only people will do the mistake. Don't choose any cloud provider here. Okay, if you choose a cloud provider, they will give only trial version of it. That means 14 days or 30 days, something they might have mentioned there. Don't choose any cloud provider. If you choose a cloud provider, that will be like, again, Azure Databricks or GCP Databricks or AWS Databricks. But we need a community edition of the Databricks. If you see there, something might have grayed out. Don't have a Databricks, click here. Yeah, exactly there. Get started with community edition. You need to click here. Please don't do that mistake. Click that, get started with community edition. Yeah, please click on that.
Okay, so guys are able to find this because they will be trying in their tab. So it's actually hidden here, like below the continue button. So I am clicking on that.
Yeah, can anyone confirm it? Okay, I can see thumbs ups. Yeah, thanks, guys. So it will ask you for some basic verification, some captcha and all. Then they will send an verification email to you. Once you verify that, then you can able to open your community edition. I can open my community edition and show it to you.
Man, captcha.
Yes, Dinesh, it will be like, it will ask you, it will test us more.
Mm. Okay.
Yeah, so now you will get an email. There, from there, you can continue with your community edition. Okay. So thanks, Dinesh. Can I share my screen and show the actual community edition of the Databricks?
Yeah, probably I even complete that as well from by
Yeah, sure.
opening the link
Okay. Yeah, you
from
can.
my email. So I just clicked on the link which I got in the email, and as you could see the username, and it is asking me to set the password. I will set my own password.
And I request each and everyone who is planning to join our upcoming sessions, series of sessions, please have this community edition of Databricks, because we are going to do with this community edition of Databricks in our upcoming sessions. Okay. Without this, you cannot practice the code.
Okay, so now I'm here, Harun.
Yeah. What it is asking, like, yeah, you can click on continue. Select the free one. Can you please zoom in? Yeah, select the standard one.
Okay, so 14-day trial starts when you click continue.
Yeah, we don't want that 14-day trial. If you click on standard, click on select standard. Yeah. 14-day free trial start when you click on continue. Okay, standard will not have that 14-day trial. You can select on standard and you can click on continue.
Understand. Okay. So did someone ask anything? I heard some noise. Okay, I'll click on continue. So can I go ahead? Account, workspace, please. Okay. Please confirm AWS account.
What is it? Can you please zoom in, Dinesh? To proceed, please confirm you have the following. You clicked on the community edition only, right? Then why it is asking?
I clicked on the community edition.
Simply click confirm. Oh, no, it should not ask this. I'm not sure why it is asking.
Oh,
Is anyone facing the same thing? Getting the same kind of thing in your thing as well?
Yeah, Harun, same.
Okay, it should not be the case. I will check and I will update you all. Okay, maybe in the next session starting, I will update you. It should not ask for any of your AWS or Azure account. It is a free version only. It's a lifetime free version. But I'm not sure why it is asking like this. Okay.
let me just give a name. Probably
Yeah, just give a name.
quick start.
Yeah, I think it is working.
And it is navigating to.
Oh, it is navigating to AWS.
Okay.
Okay, it should not. Maybe I will check with my other email ID and let you all know in the next session.
Sure.
I will share my community edition. 1 second, quickly I'll share it. So this is my community edition Databricks. Okay, here it is similar to this one, right? It is similar to, this is Azure Databricks. Okay, this is Azure Databricks.
Harun, in another tab, I am able to see the Databricks account got created, and it is to create workspace. Can I share again? Could you see?
Yeah, please. Yeah, please.
So it is showing me something like this. And
yeah, this is the workspace.
Yeah, let me create a workspace. Create workspace, quick start. Okay, let's see. I don't know. After this, it will be going to ask
AWS server.
quick start. It's going there. Okay, fine.
Okay, I will check and I will update you all. Okay.
Fine. Okay.
Maybe they changed the steps. I will check and update you.
Yeah.
So this is okay. Let me share my screen. So this is the community edition, and this is my Azure Databricks. Visually, you cannot see any difference here. Okay, visually you cannot see any difference here. Both look similar only. But as I said, there are some limitations in the community edition. That is, you cannot create a cluster with multiple executors and all here. You can create with only one driver node. Okay, but in Azure Databricks, because that is like a productionized one, right? You are going to use it for your enterprise level. There you can create how many clusters you want because you are going to pay for it. Whatever clusters you are going to use, you are going to pay for it. But in community edition, it's not like that. If they give all the executors, configuration, everything here, means who is going to go with the paid one? Okay, so that is one limitations I'm seeing here in this community edition. But for learning purpose, community edition is more than enough. Okay, so I will be sharing notebooks with you all, like basic commands from next session. Okay, so like that we can start learning with Pyspark, do data transformation, everything. I hope you all learned some basic thing today. If yes, can you all please do a thumbs up? Just understand about this session feedback. Okay. Yeah. So if we continue this series of session, how many of you will be joining again? Because we got around 80 RSVPs for this session, but only 15, approximately 15 joined. Okay. So that means we don't care about the number, but we care about the consistency. If you really want to continue, then we can have this entire series of session from basic to advanced. Okay. So yeah, Dinesh shared that meetup link. That is for our second part of the session. If you really want to join, then do the RSVP. Okay. We will meet in the next part of the session. Any feedback, anything you want to give, you can leave it in LinkedIn. You can connect with me on LinkedIn, and you can leave your comments over there. Can you please send the recording? Dinesh, are you planning to send any recording or like that?
We'll plan, Harun. As of now, we have to check, and then only we can see about it. Yeah.
Yeah. So we'll check the feasibilities of having these recordings and all, because this is a kind of knowledge sharing. This is not a kind of training session. So maybe from the next session, you can also